Okay, we've got a toy rocket and the flight path is modelled by this quadratic equation here, h being the height above the ground and t the time of the rocket's flight in seconds. And we're asked to find the maximum height above the ground that the rocket reaches and the time it takes to reach that height. Okay, well, there's really not a lot we can do with this quadratic here. Factorising it wouldn't be appropriate. The best thing to do is to turn it into a form where we can start saying what will be the maximum, and that is to complete the square. So let's do that. Yeah, we've got a problem in that we've got this -2 coefficient in front of the t squared. So I'm going to have to take that -2 out of both t squared and t. T squared's easy. But this will turn into -3t, and then our +1. Now we can complete the square just by using the two terms inside this bracket. So the -2 is going to stay outside for a while, and I tend to put that in a square bracket. So this is equal to -2 square bracket. The coefficient of the t term is 3. We're going to knock this down to 3/2. So this is going to be t minus 3/2 squared plus 1. Now I've purposely left a gap here because we need to work out what our sort of waste product is. Squaring this bracket on its own will, yes, give us these two terms here, but it will also give us an extra, well, it's going to be 9/4. Let me just prove that to you. T squared. Yep, and our two terms here, -3/2 and another -3/2, which will be -3t. So yes, we're fine up to now. We're going to get our two terms, but look what that multiplication brings us. That will give us 9/4. Positive because the two negatives multiply together to be positive. So we need to take that 9/4 immediately away from our multiplication, or we're going to change the value of our bracket here. And the big mistake is that that 9/4 is under the influence of the -2. So let's multiply out. So this is -2, and we've got our now completed square term here. Multiplying this with this, our answer will be positive. 2 times 9/4, well, the 2 and the 4 effectively cancels. So this will be positive 9/2. And then that +1, which has been sitting very lonely outside all this activity. So one more simplification. 9/2, well, 1 will be 2/2, so this will be 11/2. Again, I like to stay in fractions. I know this is a calculator paper, but decimals will trip you up and get in the way and force you to use that calculator all the time. Okay, now what can we say about this? When will h be a maximum? Have a look at this first term. The bracket involving t is determined to be positive. This being positive, the -2 will turn it negative. So this whole term is trying to be negative. When is it not negative? Well, it's not negative when t itself is equal to 3/2. At that point, this bracket becomes 0. Squaring 0 is 0. Multiplying by -2 is also 0. So I can say at t is equal to 3/2. So our bracket is equal to 0. So it will pull the value of h down at all times other than when t is equal to 3/2. So therefore I can say h will be maximum when t is equal to 3/2, and at that time h will be equal to, well, 11/2. You see, 11/2 is the value of h, provided it's not pulled down by the negative influence of this first term. So the maximum height will be 11/2. And that will be your answer.